Wait. Let me start, and then you just go. 1, 2, 3.
Okay, welcome to the periodic table packet. Again, some classes started this already. I told you if you don't understand stuff in this packet, you're not going to be able to understand the next packet, which is the hardest one of the year. All right. So again, we've lost some time with the Christmas break. Let's just move into it. All right. So the first thing you have to know is how are these elements arranged on the periodic table. All right. So elements are arranged by what? They're arranged by atomic number. All right. They'll go in order of increasing atomic number. So that's all you need to know for number one. So underneath arrangement, number one, write the following. The elements in the modern periodic table are arranged according to their atomic number. Again, the elements in the modern periodic table are arranged according to their atomic numbers. Okay. Now pause the video. Not you. Now pause the video and answers questions 1 and 2. Keep it rolling. All right. Okay. Question 1. On the modern periodic table, the elements are arranged in order of increasing choice 2, atomic number. Number 2, elements of the modern periodic table are arranged in order of increasing, again, choice 2, atomic number. Okay, now there's some definitions that you need to know. First definition is period. Okay. All right, so the word period is here. The period is the word used to define the horizontal rows. So this is period number 1 going across. Okay, this is period 2 going across left to right. This is period number 3 going across left to right. Period 4 going across left to right, and so on. So next to period, write a horizontal row on the periodic table. Next to the word period, write a horizontal row on the periodic table. Okay. Later on, you learn they get the numbers from the number of shells. Like look at Li, 2-1, it only has 2 electron shells, so it's in period 2. Everything in period 2 has 2 electron shells. All right, period 3, Na, 2-8-1, Mg, 2-8-2, that's 3 electron shells. All right, period 4 has 4 electron shells, 2, 8, 8, 1. All right, but that we get into later. The next word is group. A group is a vertical column on the periodic table. Write that down for group, a vertical column on the periodic table. Okay, and groups are important, as we're going to learn later in the packet. Groups are very important because they have similar chemical properties. The most important chemical property they have is valence electrons. Like we learned the Lewis dot structures back in the atomic structure packet. Everything in group 1 gets 1 dot because they have 1 valence electron. Everything in group 2 gets 2 dots because they have 2 valence electrons. So a group is a vertical column. And later in the packet we learn about the chemistry of each individual group. Okay, now the next 2 words are very important. All right, we're only going to do 1 for this video. All right, and you have to really play the video over as much as you can to understand it. All right, the word is ionization energy. Okay. First, let's write the definition, and then we'll talk about it. Okay, ionization energy. Write the following: the amount of energy required to remove the most loosely bound or most loosely held electron. The amount of energy required to remove the most loosely bound or most loosely held electron from a gaseous atom in the ground state. From a gaseous atom in the ground state. The amount of energy required to remove the most loosely bound or most loosely held electron from a gaseous atom in the ground state. Okay, I'm not worried about gaseous atom in the ground state. I'm more worried about energy required to remove the most loosely held electron. Okay? And the first ionization energy values are located on table S. Here's the first ionization energy values. This is what you need to know. All right, the second and third ionization energies, you're only responsible for the first ionization energy. Now energy required to move the most loosely held electron. All right, some elements have very low ionization energies. Look at lithium, 520, with a very low ionization energy. All right, you're going to learn what type of elements those are in a later video. And some elements have very high ionization energies, like helium, 2,372 kilojoules per mole. All right, so it'd be very hard to move an electron from helium. But for lithium, it only takes 520 joules to remove 1 electron from lithium. All right, so let's demonstrate. First, we're going to demonstrate, I'm going to be the atom. And this is my most loosely bound electron, my most loosely held electron. All right, I'm going to be lithium. Lithium has a very low ionization energy. All right, so Ms. Brenda Michelle's going to come in. All right, so if here I am, I'm lithium. Here's my most loosely held electron. All right, so try to pull the electron away from me. How much energy did that take? Nothing at all. So low ionization energy means they want to lose their electrons very easy, so it takes very little energy to remove the electron. Okay? But now if I'm an atom with very high ionization energy, like hydrogen 1,312 or helium 2,372, they don't want to lose electrons. They want to hold on to their electrons. So it would take a hell of a lot of energy to remove an electron. So now here I am. I'm an atom with high ionization energy. Try to pull the electron away. Right? You can't. Right? They don't want to lose the electrons. So an atom with a high ionization energy, they don't want to lose their electrons. Okay? Low ionization energy, they want to lose their electrons. All right. So if you have trouble with that, look that over. All right. So now answer questions. Pause the video and answer questions 1 through 3. Okay, let's go over questions 1 through 3. All right. All right. Number 1. Which noble gas has the highest first ionization energy? All right. All we have to do is go to the table S and look up the ionization energies. All right. So choice 1 is radon. Choice 2 is krypton. Choice 3 is neon. And choice 4 is helium. Alright, so just look up the ionization energies. I'm just going to go in order, alright, to save time. Helium is 2,372. So what you do is you write that next to the choice, 2,372. Neon, atomic number 10, has an first ionization energy of 2,081. So write that there. Alright, then you have to go down, scroll down to krypton. 1,351. And then finally radon. So all the way down. 1,037. So which of those 4 elements has the highest first ionization energy? The correct answer is choice 4, helium, 2,372. Okay, number 2 and 3 are the same type of question. That's why you have to know the definition of ionization energies. Number 2 says samples of 4 group 15 elements, antimony, arsenic, bismuth, and phosphorus are in the gaseous phase. An atom in the ground state of which element requires the least amount of energy to remove its most loosely held electron? So the least amount of energy to remove its most loosely held electron means the least ionization energy. It would be choice 2, Bi. Just look them up on table S. And number 3, same type of question. Which element requires the least amount of energy to remove the most loosely held electron from the gaseous atom in the ground state? Again, look for the lowest one on table S. The answer is choice 3, sodium. Okay, this concludes our first video.